Hello everyone. Hi, how are you doing? How was your weekend? Oh, great, amazing. That's amazing. Yeah, it's been raining a lot recently, hasn't it? Okay. Okay, so let's start the lecture today, okay? So today we will be learning about linear inequalities. So before we get into linear inequalities, I would just like to remind you guys about what we learned in the last class. So in the last class, we learned about how to draw a given equation of a line. For instance, if we have the equation as y equals 2x, how would you draw this? So we learned in the last class how to draw this. So to draw this, let's just have a coordinate axis on our hands, and then we just plot the points on this. So we learned that it will look something like this. The line y equals 2x. So given any line, let's say that you're given the line y equals 3x plus 1, how would you draw this? You would draw, it would look something like, you would first of all try to figure out what the intercepts are, okay? So for instance, at x equals 0, if x equals 0, y equals 1. So it passes through the point 1 comma 0. And if y equals 0, x equals minus 1 by 3. So it passes through this point as well. So you can draw this line as this. So this is how you draw y equals 3x plus 1. So similarly, you can draw any given line. Any given line will look something like this: y equals ax plus b. Okay, so you given any such line, you can draw, you can plot the line on the graph. Okay, so now we will be playing around with these lines and figure out how to solve inequalities using the plots that we have just discovered. To do that, let's take a case. Okay, let's take an example for starters. Let's look at the example y greater than 0. Okay, so how would you solve this? So you know the solutions, it's just y greater than 0, but how does it look on the graph? Okay, so we have to figure that out. So we'll start with just a very basic example, and then we'll move on to the complicated ones. So here we have y greater than 0. Okay, so to solve this, the first step is to solve the equation y equals 0. Okay, so the equation y equals 0 is basically this line. Oh, oops. So it's basically this line. Okay, I'll just label the coordinate axis for your convenience. Okay, so we know that the line y equals 0 is this. Now any given line divides the whole plane into two parts. Okay, so this is part 1 and this is the part 2. Okay, and the main thing, the main lemma that you're going to use to prove or to figure out the solutions of this any inequality is that all the points in a given divided plane satisfy the inequality. Okay, or they don't satisfy the inequality. What I'm trying to say is that, let's say that I pick out a random point on this upper half plane. Okay, so if this point satisfies this inequality, all the points are going to satisfy this inequality in this plane. Okay, so let's do it with an example. Okay, let's say I pick out a point here. Let's say I picked out 1 comma minus 2. So does 1 comma minus 2 satisfy this inequality? Minus 2 is not greater than 0, right? So this point does not satisfy this inequality. So all the points in this region are not going to satisfy this inequality. So let's try with the upper half plane. So let's pick out a random point. Let's say this inequality, let's say this point is what, 0 comma 1, let's say. Okay, so does 0 comma 1 satisfy this inequality? 1 is indeed greater than 0, right? So all the points in this region are going to be our solution. So this is our solution space. All the points in this region are going to satisfy this inequality. I hope that you guys understand what I'm trying to do here. Let's try to solve another example to realize what actually we are trying to do. So let's take the example y less than equal to 2x. Okay, let's say y less than 2x, not y equals 2x. So how to solve this inequality? So first of all, the first step is to draw the coordinate axis. after drawing the coordinate axis, you will solve for y equals 2x. Using the last lecture or even the first slide of this lecture, we have already figured out what this looks like, right? So it looks like a line, like passing through origin. So let's say this is y equals 2x. Now how to figure out these solutions? So what are the two parts that this line is dividing this plane into? The first part is here and the second part is here, okay? So what we do is we just pick out a random point, okay? Let's say that we pick out this point. What is this point? This point is 0 comma 3, and let's pick out another point here, 0 comma minus 3. So we'll check this inequality. We'll check this inequality on both of these points and figure out what region we want to work in, okay? So let's do that. So does 0 comma 3 satisfy this inequality? Let's check. Is 3 less than 2 times 0? No, this is wrong. Is minus 3 less than 2 times 0? Yes, this is perfectly right. So this region fails to be the solution space, while this region is perfectly correct. So this is going to be the region of our solution space. Now I have a question for you all. So before we move on to the further concepts, just let me know if you guys have any questions about how to solve these kind of inequalities. Yes, that's a very good question. What if we have y less than equal to 2x? What will happen then? Oh, oops. Yeah. So if y is less than equal to 2x, all the solutions of y less than equal to 2x can be written as either y is less than 2x or y equals 2x, right? So all the solutions, any point that satisfies either this or this is gonna be in the solution space of y less than equal to 2x. What does this actually mean? This means that y is either equal to 2x or y is less than 2x, which is precisely that y is less than 2x or y is equal to 2x. So you know how to find the solutions of this. We just proved that. And you know how to find the solutions of this. This is precisely this line right here. So what would be the solution of this? The solution of this would be the blue area, the blue line plus the green shaded area. Okay, so that is how you will solve y less than equal to 2x. We'll be doing a couple more examples about this, but before I move forward, I would like you guys just ask me any kind of questions, because we are going to solve a bunch of inequalities after this. Okay, so I'm assuming that you guys don't have any questions. Okay, so let's make this a little more complicated. Let's try to solve two inequalities in one graph. Okay, so let's pick out let's pick out y is less than equal to 2. Let's pick out 2y is less than equal to x, and let's say x is greater than 3. Okay, so we have to find all the solutions of x comma y that satisfy this inequality. Okay, so the first step, draw the coordinate axis. I'm going to do it in two different coordinate axes, and then I'm going to combine them. After you have gained sufficient experience, you can do it in just one coordinate axis as well. Okay, so first we need to satisfy both of these inequalities. So we have to satisfy the inequality number 1 and the inequality number 2. Okay, so we'll find the solution space of the first inequality, the solution space of the second inequality, and then we are going to find the solution space that lies in both of them. That is going to solve both these inequalities. Okay, so with the let's find the solution space of the first inequality. Okay, so we have 2y less than equal to x, and so what's the first step? 2y equals to x. So let's find it. What's 2y equals to x? It looks something like this. Okay, now when we'll pick out 2 points in both of these regions, so let's say again the most convenient choice is usually 0 comma 1 and 0 comma minus 1. You have to make sure that these points do not lie on this line. We need them to be lying completely in the region. They should not lie on this line, because if they lie on this line, they are going to satisfy the equality. We are trying to figure out if the points satisfy the inequality. Okay, so does 0 comma 1 satisfy this inequality? Let's check. Is 2 times 1 less than equal to 0? No. But is 2 times minus 1 less than equal to 0? Yes. Hence the solution space is going to be this. Now here's a trick. Here's a very important point to note. We had an equality here, and just like you guys asked me just now that how to solve the equality, so to do that we'll just include the line as well. So the solution space is going to be this line and this whole region. Let's now solve the second inequality, which is x greater than 3. So we'll draw the line x equals to 3. So what is x equals to 3? It's the most basic line here, right? This is x equals 3. Now we'll pick out 2 points here, 1 point here and 1 point here. Let's say it is 4 comma 0 and it is 2 comma 0. Oh, oops, it should be 4 comma 0 and 2 comma 0. So is 4 comma 0 in the solution space? Is 4 greater than 3? Yes. Is 2 greater than 3? No. Hence the solution space is going to be this. Now what we do is we combine the solution space. How do we combine the solution space? Let me show you. We'll take this graph and we'll merge it with this graph. Okay, before that I think I'll just erase this so it becomes easier to see. So what do you think is the set of points that lie in both of these areas, in the both of these regions? It's basically these set of points. Now it includes this line, but it does not include this line. So you have to make sure that you are very careful about this. So what is the solution space? The solution space is going to be this part. Okay, let me choose some other color. The solution space is going to be this line here and this region here. It's not going to be, this line is not going to be included. This is not in the solution space. Why? Because x was strictly greater than 3. So I hope that you guys have understood what I was trying to do in this example. If you guys have any questions, you can let me know now.